Hello, and welcome to the SD Core version 1.3 Techinar. Thank you for joining us. And now, welcome to our speakers today, Ankur, Badri, and Vijaya.
Hey guys, this is Ankur Padya, and currently I'm working for Intel. And previously, I worked for ONF. So I have been primarily working on SD Core 5G side, and the NFs were mostly basically SMF and PCF side. And Badri, can you change the slide to move to next slide? Yeah. The agenda for this Techinar shall be a release overview where we shall be covering that what all stuff we added. And then we shall move to cover each feature in detail along with my colleagues. And after that, followed by question and answers from the committee members. So next slide, please. So SD Core release happened on May 5th. And focus was on stabilizing network functions in cloud native environment. And also there was demand from community that for towards the 5G metric. So we added metrics framework, which community member can enhance further, and along with 5G dashboard, Grafana dashboard. Release blog and notes can be found embedded in the link on this page. And this chart release are updated in the chart repository. All the release features are well documented in SD Core document website under 1.3 branch. And I would like to mention minor information regarding code repositories for the release. They are not release tagged. However, the images, enough images, they have commit ID included in them. So developer can carve out branch according to a commit ID for particular or specific release. And I would like to thank all the contributors, which are across universities and multiple organizations. Badri, next slide, please. So here, basically, I would be covering what all features we added as part of SD Core 1.3 release. So as you can see, we employed real 5G handsets and real G-Node B hardware doing the deployment. And we added basic metric dashboard. And we improved network discovery procedure by adding network function cache to each NF. Test IMSI support has been added, which is basically IMSI starting with leading zeros to avoid conflict with commercial networks. And it is easy for developers to employ their own IMSI with real G-Node B hardware. Now, we also added APIs based UE subscription revocation. So on the fly, operators can revoke subscription of any subscriber. And this released a lot of efforts we added towards the stabilization of multiple AMF and SMF instances. Towards the high availability aspect of being cloud native, auto scaling of network function instance support has been added through KIDA, which is Kubernetes event-driven auto scaling mechanism. All the enhancement, whatever we have added, we have covered in the SD Core document. And let us know if you find any discrepancy in the document. We will be more than happy to correct them or add more details if required by any developer. Now we shall cover all the features in more details. So Badri, can you move? Yeah. So the 5G metric dashboard. So we introduced basically a new NF in the SD Core 5G. And this acts as a 5G metric aggregator and processor towards the metric consumers like analytics engine or API server or Prometheus server. 5G dashboard is available on AIB, and same information is available on SD Core document that how to visualize the Grafana dashboard. The dashboard and metric support, whatever has been added, it is just a bare framework and we have added a few stats. If you can see the screens, like number of active PDU sessions and the network function, associated network functions like UPF and GNodeB status, whether they're up or down, and their slice information on what slice they are connected. Then towards the right upper corner, if you see, you can see like how many subscribers are active with their slice information, their subscriber ID, and their status. Towards the bottom left corner, if you see, you can see the UPF throughput. So it is combined right now, but developers are free to enhance it or modify it as per their will. And towards the right corner, bottom corner, if you see, we have added some SMF stats, message level stats, so that it is easy for, it acts as a reference and easy for developer to add more stats. Okay. Next slide, please, Badri. Here I'm covering 5G metric function design overview. So if, if you observe here, we are using Kafka-based PubSub mechanism where each NF basically publishes their stats on the Kafka stream, and each NF has been assigned separate topic, so that when metric function read, it is subscribed to that topic, and when it reads, it processes those stats coming from each instance of any NF, and then collate them, processes them, and keep them organized in different data structures like subscriber level stats or message level stats or NF status level stat. Now this information right now, it is not persisted across like in the DB, it is only in memory, and consumers are like API server, which can get the metrics of any UE or NF through APIs. And then there is support for Prometheus server as well, where Grafana dashboard connects and can display the stats. And the last is analytics engine that's support for that. We have, it is just intent. We plan to probably do it in future. So next slide, please. So here I'm displaying the sample output from API service. And as you can see screen, we are getting all the subscriber through API. So we get the IMSI detail for each subscriber. And then through that IMSI, developer can fetch more information about that subscriber. As you can see, like the SMF level information or AMF level information. Okay. And then next is the GNV network function status, where through APIs you can fetch on the fly, you can fetch the status of each NF. So there are further more APIs. The information is available in the SD code document. Next slide, please. So this is another feature, static UE IP address support. So this is configuration-based support has been provided to assign specific IP address to any given subscriber. So anytime when subscriber connect, it's gonna receive same IP address. And SMF also supports UPF-based IP address allocation. And the configuration, if you see, the operator has to be careful that it assigns IP address based on the DNN pool. And that's how these IP address are blocked on each SMF instance. So that whenever UE connects, it's to any SMF instance, it's gonna receive same IP address. Next slide, please. NF cache and NF discovery response. This my colleague Vijay shall be describing in more detail. Thank you.
Thanks, Ankur. Hello, everyone. Welcome to our SD Core 1.3 release Techinar. Myself, Vijay Rani. I am a cloud software development engineer from Intel. I have been working on this SD Core 5G Ether project since 2 years. I have worked extensively on different applications like configuration manager or web UI, SIM application or GNodeB application or SCTP load balancer application. I worked extensively on these applications, and also I contributed on different 5G network functions like AMF, NRF, PCF, and all. Uh, I focus primarily on AMF side of the 5G network. So in this slide, I would like to talk about the NF cache. So NF cache functionality has been added as part of this release. So this is the addition to our project. The main aim of this NF cache functionality is to optimize the performance and efficiency of our network functions. So before we talk about the NF cache, let's talk briefly about the NRF. NRF is a centralized repository function that stores information about all NF profiles. It provides a standard interface for NF discovery and facilitate efficient communication between network functions. So when NF comes up, first it has to register to the NRF in the 5G network. So NF register with NRF using their NF profiles. So that's where NF stores the NF profiles in their repository. As part of the 3GPP procedure, if any host NF talk to the target NF, host NF queries the NRF for the target NF profiles. So NRF discovers the target NF profiles based on the discovery request information. Before it going and asking for the NRF about the target NF profiles, first host NF look at in the local cache. Is there any entry exist for the target NF profiles? If it is exist, it uses it. Otherwise, it will send NF discovery request to the NRF to get the target NF profiles. Host NF stores this target NF profiles if it received in the NF discovery response message. So it stores in the local cache. Host NF stores in the local cache. For the subsequent procedures, we can use that entry that exists in the local cache. So using this caching mechanism, we can minimize the unnecessary network traffic. Also, there are some other benefits. Using this local cache, we can quickly access the entries from the local cache, and also we can reduce the networking overhead. So, and for each of the NF profile, what we receive in the NF discovery response, so yeah, each entry is associated with a TTL value. So this TTL value is set based on the validation period received in the NF discovery response message. So this validation period is provided by the NRF. When the NF profile is discovered, it specifies the time frame during which the NF profile entry should be considered up to date. Apart of this, there is an eviction routine which runs in a different thread. So when this routine runs, during each run, it scans the local cache for entries that have exceeded TTL. Once identified the expired entries, these entries are evicted from the local cache. So now, when does this local cache get updated? So during in the subsequent procedures like service request or handover procedure, this local cache get updated with NF discovery and response messages from the NRF. So this is the common framework which has been developed for all the NF, but this feature is plugged in into the SMF and AMF as of today. And this flag is by default is enable NRF caching flag. If you see that last bullet point, that is set to false for SMF and AMF. If you want to enable it and use it for the other NF or for the AMF and SMF, you can override this flag and use it. And this NRF cache interval eviction interval time also we can configure it. We can override this timer value, and we can start using this feature. Yeah, I can move on to the next slide. Yeah, so as part of the NF discovery response message from the NRF, we get NF profiles. So for each of the NF profile, we do the subscription with the NRF. This subscription allows the NF to receive updates and notification about any changes to the subscribed NF profiles. This NF, a host NF, takes a proactive step of creating a subscription to NF profile, which means NF establishes a dynamic link with the NRF to receive real-time updates about the subscribed NF profiles. So any NF profile updates or modified, the host NF will be notified immediately by the NRF. There are two kinds of notification we can receive from the NRF. A profile update, another one is deregistration notification. If you get profile update, local cache entries will be updated, affected entries will be updated. And when you get deregistration notification, identify those specific entries which are associated with the deregistration NF profile, and we remove those entries from the local cache. This way, actually, we can ensure that our NF discovery service remains synchronized with the NRS and delivers reliable NF profile information to our NFs. So during subsequent procedures like service request and handover procedure, the host NF uh, uh, performs the requested NF discovery to obtain the most up-to-date and valid NF profile information. Yeah, let's move on to the next slide, Badri. Yeah. So revoke UV subscription from the 5G network. So this is the one of the feature we introduced as part of this release. So this is one of the requirement for one of our Pronto project. So in this project, to revoke the UV from the 5G network, we should know the IP address of the UV. So if you know the IP address of the UV, suppose in your network, if there is any UV misbehaving or exhibiting any abnormal behavior, if you want to revoke that UV from the 5G network, we can provide that IP address information to the user application. So we can here in the configuration, you can specify your user application's endpoint. So this configuration is exist in the metric function. So metric function allowing it to continuously poll for IPs from the user application. So when it gets the IP address from the user application, metric function maintains a mapping between the MCs and their associated IP addresses. So the metric function retrieves the MC associated with the UV. The metric function communicates this MC information, MC details to the rock. So SD core rock informs to the SD core to deregister the UV. 3GPP procedure SD core triggers a 3GPP deregistration procedure. The deregistration procedure triggers the revocation of the UV subscription and disconnects the UV from the 5G network. So this is one way of doing it. So using the IP address, we can revoke the UV from the 5G network. You can move on to the next slide. So this is another way of doing it. So you can revoke the UV subscription from the 5G network through ROC APIs. Suppose if you know the IMC details, you don't know the UV IP. If you want to revoke the UV from the 5G network, so you can use this set of APIs. So the first API is to get the list of enterprises. The second API, in that particular enterprise, what are the list of sites, you can get it. In the using the third API, you can get the SIM card details. So SIM card details of a particular site and particular enterprise, we can say can get the SIM card details. You can here you have to find the SIM ID of a revoking UV IMC. A revoke UV IMC associated IMC, you have to map it. You have to fetch that SIM card details of that particular IMC. You can get that you can use this sample post command is here. So here I would like to revoke this particular MC from the 5G network. So to revoke this, you have to set that enable flag to false to and send this command to the rock to trigger the UV network initiated deregistration procedure. So suppose you want to enable it back, then you can make that make that enable parameter to true to add the same UV back to the 5G network. Thank you, everyone. Yeah. Here I'm handing over to my colleague Badrina. He will talk about other slides.
Thanks, Vijaya. Hello, everyone. I'm Badrinath Padmanabhan. I work for Intel. I'm a cloud software development engineer at Intel. I've worked on SD core on various components, including AMF, SMF, and UPF. So today I'm going to take you through the rest of the slides. So multiple community members have generously contributed their time and expertise to test SD core with real UEs and GNODBs and provided their valuable feedback, which in turn has helped us make SD core more robust. To name a few, CPQD employed Moto 5G handset and bicycle radios. ONF team employed Google Pixel, Moto 5G handsets, and GNodeB from Subcom. For Pronto project, DARPA employed 5G dongle from APAL, while GNodeB was from Circom. With the feedback we received, we also enhanced SD core to support test MC. This support allows user to use test UVs having leading zeros, which is like the MCC and MNC of this MCR with leading zeros. This was one of the requests which was received after people started using SD core with real handsets and test MCs. So we've added this fix, and this also eliminates the conflict with commercial PLMs. The next topic we have on agenda is auto-scaling. Auto-scaling cloud-native network functions is a critical capability. It enables dynamic scaling of network functions based on traffic or other factors like memory or CPU consumption. Kubernetes event-driven auto-scaling, or KEDA, is an open source tool that makes it easier to implement auto-scaling for cloud-native network. There are multiple ways of auto-scaling. We have showcased auto-scaling support in SD code using KEDA in AIAB. The idea is to showcase SD code's capability to handle scaling. We can scale NFs based on memory, CPU, and even Prometheus-based events. So in the link below, we have an example of scaling SMF based on N4 request metrics. We just chose N4 request metric because that is an easy way to showcase scaling, because the N4 requests keep there are multiple heartbeat requests and multiple requests that happen between the SMF and UPF. That's where the N4 interface lies. So based on a threshold on the number of messages received in this interface, we will scale SMF. So we've added a section in the SD code docs which explains the steps to enable and use KEDA in AIAB. I'll walk you through that briefly now. So first, you have to follow all these steps, say, to get the KEDA installed along with AIAB. So first, clone AIAB, create an AIAB diff file, as we have shown in the document. I've just pasted it here. If you see, we have an AIAB diff file, so there are changes that are needed. You just need to create a diff file based on this and patch AIAB. And then create a resources. In the resource folder, you can create a keda.yaml with the details that we have given in the next slide. So here, if you see, this is a KEDA YAML. We've added the information here. In this, we mentioned that, to KEDA that this triggering for scaling will happen based on the N4 messages total. This is one of the metrics that comes out of SMF. And we put just a threshold of 50 messages. Once you get 50 messages, you start scaling SMF. So The other changes would include, like, I think, creating this SMF monitor.yaml. The monitoring file or the service monitor helps Prometheus notice the changes for or collect the metrics for SMF and then do the necessary changes and inform KIDA to do the scaling. We also create autoscale.yaml. And after that, it's similar to steps of how you set up the basic AIV, which is with make 5G core, you bring up all the pods. You do make monitoring 5G to bring up Prometheus and other components which are related to metrics. And then we've added a new target called this autoscale AIV. So you do make autoscale AIV. So after that, you should be able to start. If you do a get HPA with the namespace OMEC, you should be able to see that there's a new component which has come up, the horizontal pod scaler. And if you get the pods and grep for SMF, you will have to wait a while until the threshold of 50 and 4 messages is hit, and then you'll start seeing the scaling of SMF live. So I would encourage you to give it a go and let us know if there are any issues or if you have any suggestions on how to improve this. So we've added other enhancements. So one of them is on the enhancement on GNodeB simulator. Now we can simulate multiple GNodeBs using a single instance of GNodeB sim. We had mentioned this in the earlier Techinar. So we have this support. So using a single instance of GNodeB sim, you can simulate multiple GNodeBs. All the GNodeBs will connect to AMF with different STP connections. This enhancement will help extend GNodeB functionalities towards X and N2 handover testing. So by default, we have 2 GNodeBs. I just want to show you how the configuration looks like in the GNodeB sim. So you'll see that we have 2 GNodeBs with 2 different IPs. And then for every GNodeB, you have a different set of parameters. You give a different GNodeB ID for each of them. So like this, you can scale it up and add more GNodeBs and enhance the testing framework for that. We've also worked on interop stabilization, like I think Ankur had mentioned before. So earlier, I think the previous release, we had worked on bringing or making AMF and SMF scalable, and we had added features for that. So in this release, we work towards interop stabilization when there are multiple instances of SMF and AMF. So this will add more robustness towards the whole cloud native stateless high availability feature. The scaling of SMF and AMF instances can either be done automatically, like we mentioned before, or we can do it by modifying the SD core Helm chart configuration. We've added multiple documentation improvements, like for all the features that we've added for this release, we've added separate pages for them explaining how to use them and what this feature does, including the static IP address support, the 5G deployment guide, testing C support, metric function design overview. I think whatever Ankur went through, we have added more details to it. So please feel free to go through them and let us know your feedback. We've added information on the dynamic subscription revoking part that Vijay explained. There is a section for the auto scaling 5G NFs, and also the release notes for 1.3 explaining all the features that we have worked on for this release. I would encourage, I think, community members to please continue your contributions. Your queries can be sent on the Slack channel. We have used the workspace onfcommunityslack.com. You can use the channels etherdev or sdcoredev. If you identify value add features, please do send the proposals for review. For all the Ether users, please let us know any documentation issues that you find. You can raise pull requests on the code, document, and the Helm charts. Similarly, for the developers and the testers who are using SD Core, please feel free to raise pull requests and let us know on the Slack channel on any issues that you find. I would also encourage all of the community to join our Ether community calls on the TST meetings, which happens every Tuesday at 9 a.m. PST time. There's a link here to look at the previous meeting recordings. So please feel free to go through them. All right. So now we can jump over to the question and answers. Stop sharing. Yeah, so please use the Q&A section to go through and ask any questions that you have, so we can go through and answer them. I see some questions out here. I'll probably go through them one by one. Okay, I think the first question is static UE IP config. Can this be only done through? Can this be done through API, or can it be done through Ether portal? So that's one of the questions. Ankur, you want to take that?
Yeah, I can answer that. So right now, static UI IP configuration is only available through SMF configuration, which can be done in SD Core help charts. So right now we don't have support through Ether portal, unfortunately.
All right. The next question is, can auto scaling be made part of AIB setup with a different makefile target? So yeah, as I explained, we've added how to integrate this auto scaling part inside AIB. We've added the example of SMF. I would encourage all of you to please try it out for other NFs, for AMF and SMF. At least these are the ones we have tried, and we have added the stateless capabilities and to recover from and handle multiple instances. For these, we have worked on AMF and SMF. So I would request all of you to give it a try. But there are examples out there, more other examples where you can use any other auto scaling mechanisms also. But at least for AIB, you can start using Kira right away. Let's see what else we have. Okay, I think there's a question from, what is the max number of UEs that can be connected to the SD core? And what's the reason for this UE limit? Okay. Uncle, you want to take this, or Vijay?
Yeah, I think so. We haven't tried out the max out the capacity, but with two SMF instances, we could reach around few hundreds, and beyond that, we have not tried. So, what is the upper limit? So, I think with more number of SMF instances, community member can just give a try.
Yeah, I think theoretically, I think we don't have. I think we have like some 8,000 or 10,000 users per SD core instances, but I guess it's not tested fully. So yeah, like Ankur said, the community is encouraged to please give it a go and try it out. The question: what is the max number of GNodeBs with this multiple GNodeB support in GNodeB Sim? How many GNodeBs can we add? Vijay,
I'll take it up. Max number of GNodeBs we haven't tested, but we configured 2 GNodeBs in the configuration file. With 2 GNodeBs, we tried to attach some subscribers through one GNodeB, some through other GNodeB. So max GNodeB count as of now we don't have. Okay. But we can have more than 2 GNodeB support.
Okay, it's one interesting question that we have. What are the use cases to have multiple SMF? Uncle, I'll direct it to you.
So it is towards the cloud native support where you want to have a higher availability support and stateless session support. So suppose PDU session is running on SMF instance 1 and it goes down for some reason. So the SMF instance 2 or any another SMF instance can take that PDU connection and do the update or whatever next procedures. So that is the reason.
Okay. Thank you. There's
Yeah,
one more
there is
question.
one question.
Mhm.
There is one question. Is there any simple ROG GUI to enable or disable UV subscription? So yes, there is a ROG GUI. So it is there in Ether project documentation. So there, I'll answer to this question in the chat box. I'll provide the link to that.
Thanks, Vijay. So there's a question on, can you please provide more insight on how community members are writing SIM cards? I think we were using one of the tools for writing the SIM card, at least for in our case, but I think we had downloaded. I don't know if it's available on. I think we used a particular device we ordered on Amazon to write the SIM cards. But I can probably provide more details on Slack channel. Please ask the query on Slack and we can take it up there and gather more information on that. Let's see what else. Are there more details online about the test rigs and test cases? This is one of the questions. I would probably encourage you to please join the TST meetings where we have more detailed information we can provide on how we are testing and what are our test setups. There, I think it would be better to join that and get more information. We don't have anything online specifically for this. Right. Yes. Questions on any updates on the AF HTTP mode UPF? Yes, I guess I think I will again say the same thing. Please join the TST meetings. I think there are you might get more updates on all the UPF related changes that is happening on that. Probably it's not part of this release, but you can join the meetings and you can get more information on that. You can also query us on Slack. I guess there are other members who are community members who are working on the UPF where you can get more information. Is static IP address applicable only to 5G? What about 4G?
Yeah, 5G has, we have introduced in the 5G. 4G, I'm not sure, probably I can get back to this
I
question.
think we already have in 4G. It was part of the HSS configuration. This was previously tested. So you can mention you can add the configuration in HSS for the UE subscription to have a static IP in 4G case. So please give
Right,
it a
it may not be the same configuration.
not the same one. Yeah, that's a different configuration.
Yeah. Different in 5G.
Is there available a comprehensive list of GNodeBs and UE already integrated? I think in one of the slides that we presented, whatever slides, whatever the GNodeBs and UEs we have tested with SD Core by ONF, like there's Moto 5G and the Circom GNodeBs. There was some used by the Pronto project, and also there's information for the CPQD. Apart from this, we try to collect all the probably a better list from the community, and we can probably add it to the SD Core. We'll take that SD Core documentation. Probably we can take that down as a point. Is the GNodeB simulator capable of achieving gigabits throughput?
Yeah, I'll take it, Padri. So GNodeB simulator, as of today, we can simulate only ICMP traffic. We didn't integrate this GNodeB simulator with any of network traffic generators like iPerf. So if you could integrate with that, probably we can achieve this gigabits. That part we have to do. Yeah, that will be in our future roadmap. Yeah.
Right. I think last probably question is about, is there any tutorial about SD Core and SD RAN integration? obviously able to work with both. We probably don't have a documentation, but I can find it out. There were some, I think we have tested with, there's SD-RAN in a box, which uses SD core and the SD-RAN itself. Probably you can ask this query on Slack. We can point you towards the right documentation, which where you can use the SD-RAN box itself.
Right. You can mention your problems, like what you are facing, so community member should be able to help you in that regard.
I think this probably the last question is on probably the future enhancements for 5G. I guess Ankur, you want to answer that? Or I think the general consensus or point is to please join the TST meetings. We discuss all the new features which happen there. You can request new features or bug fixes, and all of this are tracked on the TST meetings in the community calls. So highly encourage everyone to join that.
Right, like more feature enhancement and what's going with SD core. It's all discussed in TST meetings. So
yes,
yeah, every developer, keen developer should join that meeting.
Just reminding, Tuesdays, 9 a.m. PST. One more question. Have you used any other ORAN compliant G0B other than CIRCOM with SD core? I think there was, I'm trying to remember which one we used in, I mean, we've used one more. I'm not able to remember that, but yeah, please, I guess, again, if you can post it on the Slack channel, I'll be happy to answer it and get the information for that. I think we did try with one more, which was ORAN compliant. No questions. Oh, can we integrate metric function APIs in Ether Rock GUI? Ankur, you want to take that?
Yeah. I'm not able to understand the question, like metric function APIs in Ether Rock GUI. So as I understand, the ask is, can the APIs which are used for fetching the raw metrics from the metric function, can they be clubbed with dashboard of Rock? So, I mean, yeah, anyone is free to use those APIs. So APIs are available with metric function.
Yeah, I mean, please try it out as an enhancement for Rock and SD core. So definitely. Okay, one more question. Do you know if the this version of SD core already supports Suki profile A or B, or only null profile? Vijay,
Yeah, it is null. Yeah, it's null profile.
As of now,
We test. As of now, it is null profile. I think in pre-5GC code it is there Suki profile A or B, but we have not tested it. With null profile only we tested.
Okay. Thank you. We'll probably wait for some more time to see if any other questions pop up. All right. Okay, I think.
Okay. Well, I appreciate everyone joining us today, and certainly thank you to our speakers for sharing their knowledge, these members of the SD Core team. Following the meeting, we will send everyone that joined us an email that includes the video recording and a link to the slides. Thank you again, and this concludes our broadcast.
Thank
Have
you.
a good day.
Thanks, everyone.